So here we're going to look at assigning oxidation numbers, figuring out which substance is oxidized, which substance is reduced, and then we're also going to look at determining the number of electrons lost and gained in total. So first thing I'm going to do is go through and assign my oxidation numbers. And again, I always put my oxidation numbers on the bottom, and then I do my work kind of on the top. And the reason I do that is because I want to add up to the overall charge on that molecule or ion, whatever it might be. So looking at K2CR2O7, I know the potassium is always a +1 oxidation state. Oxygen is always a -2 oxidation state. So from the potassiums I have +2, and from the oxygens I have -14. So I need +12 from the chromiums. So this becomes a +6 because there are 2 chromiums there. Notice I'm not worrying about the balancing. I'm just focusing in on each molecule here. Next one is a +1, -2. That's pretty straightforward. Sulfur is 0 because there's no charge on that. This is a -2, so that gives me -4 +4. So this is a +4 oxidation state. +1, -2, +1, that adds up to 0. And then this is -2, so it's -6. To add to 0, I need +6. So it means that each of those 2 chromiums there has to be a +3. Okay, so now if we're trying to figure out what substances are oxidized and reduced, I'm going to look at my chromiums first. They are going from +6 to +3, so that is gaining, or GER, I'll put GER for gaining electrons, and that is gaining 3 electrons per chromium. We'll get to that in a second. Now the other one is my sulfur, goes from 0 to +4. That's losing, so my LEO, or loss of electrons, is oxidation, and that's losing 4 electrons. So if we wanted to talk about the substance oxidized and substance reduced, so I'll write this off to the side. So the substance oxidized, what was oxidized is sulfur, and what was reduced was Cr. So when we're talking about the things that are being oxidized and reduced, we're looking at the elements, who's gaining and losing the electrons. Now, if we're going to do the oxidizing agent and the reducing agent, we're always talking about the compounds that come from. And remember that if you are oxidized, you are the reducing agent. If you're reduced, you're the oxidizing agent. It's basically the opposite, right? It's almost backwards. So sulfur is losing electrons to chromium. So that means that since sulfur is losing, it's causing chromium to gain. So sulfur is the reducing agent. And since since chromium is taking sulfur's electrons, it's causing sulfur to be oxidized. So K2CR2O7 is my oxidizing agent. So it's chromium's compound. Notice that all of these come from the reactant side, because that's where the transfer of electrons happening. The products are what's remaining after this has taken place. So now we're going to look at our electron transfer. How many electrons are transferred? So if we look at, let's start off with sulfur, because that's probably the easier one. So sulfur, it loses 4 electrons. 1 sulfur atom does. But there are 3 sulfur atoms. So it loses 4 electrons per sulfur. So we're going to times it by 3 sulfurs. I'll just take that out. I don't want to confuse things here. So that would make a total of 12 electrons lost. Now let's look at chromium. Let's talk about each chromium. They go from +6 to +3. So that's a gain of 3 electrons. But there are 2 chromiums here, and then looking at our balancing, there's another 2 there. So there's actually 4 chromiums in total. So gaining 3 electrons times 4, that's a total of 12 electrons gained. So that means that our electrons lost and gained are balanced. So if you have a balanced reaction with coefficients in front of all these things, the electrons lost and gained, the total electrons lost and gained should always be the same. Otherwise, our equation's not balanced.